So this is a next lecture, and in this lecture what I will show is I will show how to represent the complex numbers in xy plane or using Cartesian system, Cartesian coordinates. So the complex number u can be given by x plus jy. So it's possible that you can represent it in Cartesian system by using two axes, the x-axis as the real axis and the y-axis as the imaginary axis. So simply if we can draw this, it would be something like this. This is my x plane and this is my y plane. This is my positive x-axis, while this is my negative x-axis, and again this whatever is my positive y-axis, and this is my whatever goes here is my negative y-axis or negative x plane. So if I want to represent a point like my complex number is 3 plus or 3 minus 2 j2. So 3 is what is coming in my x, and this will be, I can draw it like this, and my minus 2 is what is coming in my y. So this is my minus 2, and wherever it will meet, if it meets at here point, this is what is my u. So u is equal to 3 minus j2. So again it's possible to do the addition of the complex number in a way very similar to which you did in vector. So if we are doing addition using graphs or using coordinate system representation is possible to do. While I'm demonstrating this is not as per scale. This is just to represent. So if we are drawing this, if this is my first complex number u1, and if I'm having another complex number which is given by u2, so I want to add these two complex number, that is u is equal to u1 plus u2. So it's possible to do it directly by projecting it in this way and adding it very similar to how you would have added a vector. So this is my u2 and u is equal to u1 plus u2. So in a way very similar to how you would have added your vector. It's possible to add the complex number, while there will be nothing like a head or a tail here. It will be just it can be represented by dots, and what you will do is you will place the u2 on top of this. That's how you are adding. So again that was the addition, and if you are simply doing the subtraction also, if this is my complex number z1 or this is my complex number u1 and I'm having another complex number u2, so if I want to do u is equal to u1 minus u2, then the negative of u2 will become something like this. It has to be drawn exactly opposite, and this is my x and y coordinates respectively, and when I am doing I will have to project it exactly on top of this, and you will have to keep, if you are drawing this, then you will have to keep in mind whatever is the angle. This is theta 1, this is theta 2, so this will be again what will be, this will be theta 2, and when you are taking it from here, this is whatever angle you are drawing it, this is your theta 2, and whatever you are getting here, this is your u, it is equal to u1 minus u2. So this is how it's possible to represent the complex number given by u is equal to x plus jy by considering the y as your imaginary axis and x as your real axis, and it's possible to represent the same thing using complex numbers. So again, if when you are having quantities which needs to be resolved in vectors, it's possible to represent the vector components in form of the component which lies along x-axis. So this is just to consider if you are having a current which is given by a vector quantity which is 100 plus j800. So if you are having a vector, so it's simply possible to represent the quantity in along the x-axis and the quantity along the y-axis. This is 100 and this is 800. So this is what is my total value of the v1 will be. This will be my phase angle phi. So the phi angle will be found can be founded by tan inverse of y by x. This if this is your x and this is your y. So this is how it's possible to take this whole idea into solving problems related to electrical engineering and the other engineering which is involving vectors. So it makes doing calculations very simple by considering the complex numbers.